Our topic for this lesson continues to be from our probability unit, compound events with tree diagrams and tables. Our essential question is, how can we use diagrams and tables to help us calculate probability of compound events? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header along with today's date. Set up your question column and your note column and resume the video when you're ready to begin. So today, as we mentioned in the topic, we're talking about compound events. So I want to start with some examples of what compound events are. Here are three: flipping a coin multiple times, rolling more than one die, choosing combinations of different outcomes. These three and many more are examples of compound probability because we're looking at more than one thing happening in a sequence or at a time. So we have to take a few more things into consideration when dealing with compound events, and diagrams and tables are going to be really useful in helping to make sure we accurately calculate the probability. Let's take a look at our first problem. We're being asked to use a tree diagram to find the probability that you will get any combination of 2 heads and 1 tails if you flip a fair coin 3 times. So we've done a lot of work with coins, and we probably already know that if I was to just flip 1 coin, the probability would be 1/2. But we want to see what happens if I flip 3 coins. Okay. So here I've written out the problem, the probability of 2 heads and 1 tails. We do need to be careful that it does say any combination. Some probability questions and compound events will state a specific order in which this has to happen, but this just says any combination of 2 heads and 1 tails. So here we're going to have our starting point. We're thinking about what's going to happen, and if I flip a coin, one of 2 things is going to happen, right? It's going to be either heads or tails. So in a tree diagram, we draw branches for what is the outcome of the first event. What are the possibilities? So my first coin flip, I could get a heads or I could get a tails. So then we're going to flip the coin again. Well, if the first time it landed heads, then again I have 2 more options of what could happen. If I'd gotten a heads the first time, then the next option is it could be a heads or a tails. So in this case, the first time I would have gotten a heads, the second time I could have gotten a heads, or the first time I could have gotten a heads, and the second time I could have gotten a tails. But what if, in that first coin flip, I'd gotten a tails? Then I could have gotten a heads or a tails again on my second flip. So now you're starting to see these are the branches of why we call it a tree diagram. We're trying to keep track of all the possibilities that could happen in a compound event. So now we have what it could look like if we flipped once, and if we flipped a second time, here are the outcomes. And now we need to consider if we flip it 1 more time. So you can start to see that I have my branches drawn. Again, for each possible outcome, we have to state that on the third flip, we could have gotten a heads or a tails, or a heads and a tails, or a heads and a tails, or a heads and a tails, depending on what happened before it. So if you haven't done so already, please take a moment and make sure that you have this copied in to your notes. And then let's continue to analyze this tree diagram to see if we can figure out the answer to the question. So the question asked us to find any combination of 2 heads and 1 tail. So we want to look at this and see, where does that happen? Well, I could start with a heads, get a second head, and then get a tail. So there's 1 trail. I could also have gotten a heads on my first flip, then a tails, and then gotten a heads. Here we would have gotten 2 heads and 1 tails, or here we could have gotten 2 heads and 1 tails, just in a different order. Heads, tails, heads. of getting a heads first, these are the only two possibilities. But can you see one more place where we have a combination of getting 2 heads and 1 tail? Right here. We could have started with a tails, then gotten a heads, and then gotten a heads again. That would have been 1, 2 heads, 1 tail. These other combinations don't work. Tails, 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 that doesn't meet the criteria. Tails, tails, heads is the opposite of what we're looking for. And tails, heads, tails is also the opposite. That's 2 tails and 1 head. So it looks like there's 1, 2, 3 favorable outcomes. So we could start to put our numerator of 3. But how do we figure out what the total possible outcomes are? Well, pause the video and think about that, and then return to see if we both agree. I found a total of 8 possible outcomes. I could have gotten heads, heads, heads. We have gotten 2 heads and a tails, which we had counted in our favorable outcomes. I could have gotten a heads, tails, heads, or heads, tails, tails. So far that's 4. Or I could have gotten a tails, heads, heads, a tails, heads, tails. There's 6. Or tails, tails, heads, or lastly, all 3 tails. So that was in total of 8 outcomes. A nice shortcut with tree diagrams is that you can also just count up the ends of the branches. 1, 2, 3, 4, 5, 6, 7, 8. Because that always shows you the total possible outcomes and the end result. So if you count that up, that'll always give you your denominator. Let's look at one more way to calculate probability of compound events, but use another method for organizing our thinking. Here we're going to use a table, and we're going to use that to help us find the probability of getting a sum of 5 when rolling 2 dice. And I've already actually set up our table, and there's some things I want you to notice. I made rows, right? All the times getting a 1, all the times getting a 2. So I made rows for the first die to show all the possible outcomes, and these are the 6 possible outcomes. And then I made columns to show the 6 possible outcomes with the second die. And this question is asking us to find the sum. So I've already filled in a few numbers in the table, but I did incorrectly, didn't I? Caught that right there. I did multiplication on that first one. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Here's an example. 4 plus 3 is 7. So go ahead, create your table, and then fill in the rest of it. If you have enough information from there, go ahead and try and answer the question of the probability of getting a sum of 5 with our 2 dice. Alright, so your table should start to look something like this. And you can see I've boxed in the sums here where we added up all the numbers. And I've made you a little note here that kind of like with the trees, one of the things that's nice about a table is the number of cells that are inside your table tell you the total number of possible outcomes. So because this is a 6 by 6, right? 6 across, 6 down, there are 36 total outcomes. So we could put this in here and say, well, we know that that's going to be 36. Now we just have to figure out how many of them have a sum of 5. So let's take a look. So it has to be exactly 5. So it looks like we have this right here, these outcomes that I'm trying to circle. 4 plus 1, 3 plus 2, 2 plus 3, 4 plus 1. So there's 1, 2, 3, 4 out of 36 possible ways to get a sum of 5 when rolling 2 die. So let's go ahead and mark that up. Count up 4 of them. So 436. I'm noticing something here about this fraction though that can reduce. So we definitely want to do that. Go ahead, reduce your fraction, and then compare to see if we got the same thing. So we can divide both 4 and 36 by 4. 4 goes into 4 once. 36 divided by 4 is 9. So our final answer is the probability of getting a sum of 5 when rolling 2 dice is 1/9. Again, we could have written that as a decimal or a percent, but I'm going to go ahead and leave mine as a fraction. That concludes our video today on introducing compound probability.